Okay, let's dive right into this. Today, we're looking at a single author's really sweeping and honestly radical critique of modern physics. The whole idea here is that some of the most foundational concepts in science aren't just a little off, they're closer to magic than they are to mechanics.
And let me tell you, he does not pull any punches. This opening quote, it really sets the stage, doesn't it? It's a provocative argument that challenges ideas a lot of us just take for granted.
Now, just so we're all on the same page here, our goal is simply to unpack the arguments as they're laid out in the source material. We're not trying to prove them right or wrong, we're just exploring the critique itself. So, the core idea, the central claim of this whole thing, is that for nearly a century, whenever theories didn't quite match up with the data, physicists have just invented these non-physical patches or fudges to make the math work, instead of actually going back and fixing the foundational equations. Yeah, this quote it says it all, right? So to really get what he means, we're going to walk through two specific case studies from his work, where he claims these fudges have completely hidden what's really going on. All right, first up, we're talking about the Drude-Sommerfeld model. Now, this is a big one. It's a foundational theory that's supposed to explain how electricity and heat move through metals. The basic picture is a kind of gas of free-flowing electrons. And the original Drude model was actually pretty successful. It got a lot of things right about metals. But, and this is a huge but, it had one massive, glaring failure. It predicted that the electrons should contribute way, way more to a metal's heat capacity than they actually do. This failure led to what the author calls quantum mechanical additions to fix it. Okay, so get this. These are the fixes. According to the author, things like an electron's mass suddenly becoming effective or, get this, even negative, or inventing imaginary particles called phonons. He says this isn't physics. He argues they're just mathematical tricks designed to force the theory to fit the numbers, all while completely ignoring the real crystal structure of the metal itself. So, if the standard model is, in his view, just a series of patches and fudges, what's the alternative? What does he suggest is really happening inside a metal? He proposes something completely different. A sea of real, physical photons. He calls them charge photons. In his view, this photon field is the real mover of energy and charge, and it's what we should have been studying all along. And this is super important. These aren't the virtual particles you might have heard about in quantum field theory. He's claiming they are literally real. His proposed mechanism is actually pretty straightforward. This photon field moves through the metal, and the free electrons, they're just getting dragged along for the ride, kind of like buoys on the surface of the ocean. He argues that for 100 years, physicists have been mistaking the motion of the buoys, the electrons, for the current itself, which is actually the water underneath. And this brings us right back to that original heat capacity puzzle. The author claims it's solved by a concept he calls charge channeling. The idea here is that heat capacity isn't just about mass. It depends on the specific structure of each element's nucleus, which determines how efficiently it can channel these charge photons. So, that's a pretty huge rewrite of solid-state physics. And if this proposed photon field is the answer here, the author asks, could it also be the key to another famous quantum puzzle? And that brings us to our second case study, quantum tunneling. You know the one. The famous idea that particles can magically pass right through barriers they shouldn't have enough energy to get over. The author sees this not as some deep quantum truth, but as another magic solution to a problem that shouldn't even exist. His argument here is just incredibly blunt. Particles don't tunnel. Period. He claims the only reason we even need a concept like tunneling is because the foundational equations we use to calculate those energy barriers, like the Schrödinger equation, are themselves deeply flawed. If the equations were right, he says, we'd see there was no barrier to tunnel through in the first place. And just to give you a sense of the scale of the error he's talking about, he connects it to the infamous vacuum catastrophe in physics. This is where the theory and actual observations of the vacuum energy of space differ by an absolutely astonishing 120 orders of magnitude. For him, this is Exhibit A, that the foundational field equations are completely, totally missized. And this table just lays it all out so perfectly, doesn't it? It shows the two completely different worldviews we've just explored. For heat capacity, the mainstream uses ideas like phonons and screening, while the author proposes nuclear charge channeling. For quantum tunneling, the mainstream relies on probability and the Heisenberg uncertainty principle, while the author just says, no, it's just flawed equations and the real motion of photons.
So, wow. After deconstructing these two major pillars of modern physics, what is the author's ultimate conclusion? What are the implications if his critique actually holds true? Well, the final claim is that this isn't about small corrections. It's a call for a complete overhaul. According to the author, the foundational equations of quantum mechanics are broken and need to be rebuilt from the ground up, this time based on the mechanics of a real physical photon field that carries charge.
And that leaves us with a fascinating question to think about. In any scientific field, theories get patched and amended all the time. That's how progress happens. But at what point do those fixes, those little fudges, stop being clever solutions and start signaling a deep foundational flaw in the theory itself?